Hi there. For this video, we are given the problem, let f of x be equal to 1 plus 1 over x plus 1 over x squared plus and so on, with absolute value of x greater than 1. If f of x over x minus 1 is equal to 10, find x. So before I answer this problem, feel free to pause the video so you may try this one first on your own. Okay, so let's start. So to solve this problem, first take note that f of x out here is an infinite geometric series. Indeed, observe that we can write this one as 1 plus 1 times 1 over x plus 1 over x squared and plus so on. So clearly, this is an infinite geometric series with first term given by 1 out here and common ratio given by 1 over x. So now that we know this, what do we do next? Well, what we can do is we recall that given an infinite geometric series, say a sub 1 plus a sub 1 r plus a sub 1 r squared and so on, this sum is equal to a sub 1 over 1 minus r, provided that the absolute value of r is less than 1. So that means we can express this function into this form. But we still need to show that the absolute value of r must be less than 1, or that is, the absolute value of 1 over x is less than 1. Fortunately, we are given this one out here. So let's try to use this one. So we have here the absolute value of x is greater than 1. Since we want to obtain 1 over x, we can divide the absolute value of x both sides to obtain 1 is greater than 1 over the absolute value of x. Now from here, let's try to use some properties of absolute value. Take note that this one is equal to the absolute value of 1 over the absolute value of x. Moreover, this is equal to the absolute value of 1 over x by a property of absolute values. We know that the expression here inside the absolute value is r. So therefore, we obtain that the absolute value of r is less than 1 from here. And so that means that we can use this formula, or that means we can express f of x in this simple form out here. So let's do that one. So we have here f of x is equal to a sub 1 over 1 minus r. Our a sub 1 in this case is 1 over 1 minus r in this case is 1 over x. So this is the new form of our f. But to simplify things further, we can multiply x over x out here. Note that we can do that since we know that x is not equal to 0, since, again, absolute value of x is greater than 1. So this is just equal to x over x minus 1. And this will be the form that we'll be using. Oops. So again, we have here f of x to be equal to x over x minus 1. So to find x this time, we'll use this one out here. So using this one, we know that 10 is equal to f of x over x minus 1. So what we do is we simply plug in this value in here. So we'll have here x over x minus 1 all over x over x minus 1 minus 1. And in here, take note that we can multiply the numerator and denominator by x minus 1 to simplify things. Again, we can do this since we know that x minus 1 is not equal to 0. Since, move this one out here, we have x is not equal to should be positive. X is not equal to 1, which is indeed true since we know that the absolute value of x is greater than 1, not greater than or equal to it. So we'll have here, this is green, we'll have here x on the numerator, and in the denominator we have x minus 1. So we multiply this in each term out here. Simplifying this, so we distribute the negative sign out here, we'll obtain x over x minus x plus 1. And x minus x out here, we just cancel out to 0. And so we're left with x. And what do you observe here? Observe that the left side of the equation and the right side of the equation is what we want, since we have 10 and x on the right. So we know that we can conclude that x is equal to 10. And that is the answer for this problem. So we have shown that the way to answer this problem is using the concept on infinite geometric series. Since we were able to simplify this never-ending function into just a simple form, and we just use the given condition to find x. So it's just as simple as that. So I hope that you were able to answer this one, and if not, feel free to rewind the video in some parts so that you will have a greater understanding on how to solve this one. And if it's still hard to figure things out, please don't hesitate to comment down below, and I'll try my best to respond and help you answer this problem. So that's it. I hope you enjoyed this one. And yeah, that is all for this video.